So ladies and gentlemen, boys and girls, they won't know. Okay, so I'm on Igbo attire, and today I'm trying to answer questions. Okay, I'm trying to answer 10 questions from my Twitter followers. 10 to this question from secondary school level to BSc level. And somebody said, this person at KC Udena said, differentiate between voltage and current to a layman. So I'm just going to be very brief on this video. First of all, before I start, I would like to tell you that voltage is the work done over charge, equation 1. Then current is what? Charge per the rate of charge, the rate of flow of charge, equation 2. Let's stop here. First of all, let's use a tap, a physical system like a tap. When a tap is flowing, the flow of that water is the charge. Now, what makes that water to flow is actually the voltage. The voltage, you can say that voltage is equal to pressure, because increase in V equals to increase in pressure. Now, that water is flowing because if you increase the voltage, that means the pressure at which the water will be released, okay, is now the voltage. And according to theory, we know that voltage is the potential difference. Let's just say this is a terminal A to terminal B. The potential difference to move, or the work done to move a unit charge from this point to this point, okay? And that is what? From the PD. The PD across one terminal to another terminal is the what? The voltage. So the voltage is what work done to move a unit charge from one point to another. While current is what? The rate of flow of charge. So you can actually call current the rate of flow of charge, right? Now, let me tell you, when the pressure of a fluid or water, or the water is running, or let me say the voltage of, let's just use a bulb, when the voltage is high, right, of course the impact will be high, okay? But now that doesn't determine the current. But in currents, right, as the water is flowing, okay, the amount of flow of charge is what the current entails. So when, no matter the amount of pressure or voltage exerted on the water, right, it does not tell you that that's the amount of charge or current you will get. No, the amount of current is the quantity that flows. If you increase the voltage, it doesn't also tell you that increase in voltage must give you increase. It can only give you increase in pressure, but it cannot determine the amount of current. Now, when we're using tap water, you can see how we have been able to use tap water to break this thing down in physical terms. So now, that is the difference. Voltage is just work done per unit discharge. The work you are exerting and the charge. While current is the flow, current is the amount, current is the quantity of the water. Like if you fetch water inside a bucket, current is the amount of water that you got. Voltage is what pushed it, the force that forced it, the medium. And now current is dependent on voltage. You know why? Because when there's no voltage, when there's no pressure, current will not flow. And that's why even in a circuit, they have a switch. When you open the switch, you have opened up the voltage. You have opened a room for PD to flow, or voltage to flow from one terminal to another. When you lock the switch, there is no current. When you switch off the switch in your house, there is no more current. And that's the difference. Thank you.